Hello and welcome. You may recall that in the previous installment of this series, I implemented a novel work submission system. Now, as much as I would have loved to persist with it, there were some major issues. Number one, if something goes wrong during rendering, a robust system should be able to flush out the graphics queue and recreate resources. But having a whole lot of threads pumping out at the same time, it just wasn't practically possible to synchronize that to save it from disaster. So that's not good. But number two, in theory, spacing out the work submission should increase the throughput, but in practice, it was choking the graphics queue with a lot of non-useful work. So for example, although I had threads individually going graphics like render, submit, present, I was just getting a lot of render operations being queued up without submit operations. Like, it was slowing things down. So for those reasons, I'm simplifying the rendering code and I'm rolling things back a little bit. This session should follow on from part 12, which was synchronization. By the end of that session, we had a triangle rendering and it was mostly working. So if this is mostly working, then what's wrong with the way things are currently done? Look, the honest truth is probably nothing's wrong with this. Depending on the system and depending on the work that's being done, this could be just as performant or could be diminishing returns. But I'm going to talk through this anyway. So the way we're currently going about this rendering is at the top of our rendering function, we wait for the previous frame to finish. Then we request a new image index from the swapchain. Then we go and submit a command buffer to render to that frame of the swapchain. And then we enqueue a request to present that swapchain frame to the screen. And we can see here on this diagram with these arrows that there's some dependencies amongst these tasks. If we overlay several of these, like 2 rendering operations, we can see that, one frame is waiting for the previous frame to render. In the healthy spirit of number go up, we can improve this a little bit. So the frames in flight technique sits somewhere between the naive method that we're doing at the moment and a fully multi-threaded approach. We feed work to the GPU in a serial manner, but it's interleaved. Imagine 2 virtual frames named A and B. The idea is that we submit everything for frame A, and then while the GPU is working on frame A, we submit everything for frame B, so that frame B is not immediately waiting on frame A. And then it's in the GPU's hands. It's magic. But the idea is that we're feeding the GPU with more useful work continually. So let's get into it. To start with, I'm going to do a pretty large amount of refactoring. Why not? One refactor is I'm going to rethink the definition of what a frame is in the engine. So previously I've been using frames as sort of a catch-all, and I've been associating everything like a swap chain image, command buffer, everything with a single frame. But this has caused some weird workarounds because the frame is not really being used as a frame, if that makes sense. Here's a new definition. A frame is a set of all the state, synchronization structures, command buffers, etc., needed to render a frame. This means that frames will need to re-record their command buffers every frame, but that's not a big deal. It's pretty standard usage. So to start with, let's change the constructor and member variables for a frame. The constructor is pretty much what it looks like. All references are captured in the initializer list. And whatever's going on here, we get rid of it. Just a quick note that clearly I'm not capturing all references. I'm sort of looking ahead a little bit. Not all of these things need to be saved. And the reason I'm doing this is because I recorded this video previously and then forgot to hit the record button, so I'm speed running this right now. It's okay. Okay, we'll leave the rest of this for now. Now in the engine's initializer, here we are, we can see that we're touching these frames twice. The first time we're going through and we're creating the swap chain images for them, basically. And then the second time we're going through and we're setting their command buffers. Now, we do not need to do this, so we can get rid of all of that, because now the frames are going to know nothing. They're not going to have dedicated swap chain images. They'll be getting them on the fly. We're going to have two frames here, doing an A-B approach. And yeah, let's get into it. Okay, great. So that has constructed all of our frames. If a frame is all the context needed to draw a frame, then a swap chain is all the data needed to define a draw target. In other words, what I'm getting at is we need to make the swap chain class manage its own images and image views. Okay, no problem. We'll start by declaring public member variables to hold those resources. Okay, now we can go to the constructor for the swap chain and we can fetch and build the images and views. Okay, looks good. We got through it. So we got the images and image views bound to the swap chain. So every frame has a reference to a swap chain. All we need to do now to record a command buffer is pass in the image index, the position on the swap chain where we want to render. So our process for rendering is going to go something like this. First of all, we acquire a swap chain image. The function immediately returns the image index, while in the background the GPU prepares that image for rendering, presentation, something like that. Then we tell the current frame to record commands to render to the given image index, and then we go through the normal work of rendering and presenting. We are going to need to slightly modify things though. So for one thing, we've got this function here, set command buffer. We don't need, it's not, we're not going to call it that. We're going to call it record command buffer. And all we need to take in is the image index. Okay, now these other functions do not need to take as much info, right? So we don't need a frame size because we've got a swap chain. We can query it. But in order to build the color attachment, we need to know which image view we're attaching to And for that, we're going to need the image index. But then likewise for this other function, we're not going to need those other arguments. There we go. Okay, so I'm just going to jump through the frame function. It'll just be a number of straightforward refactors. Oh, I forgot this. We should probably reset. All right, so build color attachment, we'll pass in the image index. Build rendering info, we need nothing. And then here where we've got frame size, that is, oh, it's not necessary. Not necessary at all. This function is fine. Then build rendering info. So where it says frame size, instead of that, we can simply get our swap chain and query its extent. For image view, we will get our swap chain. I missed something, just super quickly. That's fine. Oh yeah, we don't need this. Image and image view are gone. That should help. Okay, so for the image view, we're going to go get the image views and then use the image index to access the appropriate one. And we should have up above something very similar. Yep. So we'll get our swap chain, images, and get the appropriate one. Okay, and then likewise, this will be, yep, the swap chain extent. Okay, so fingers crossed that should all be set up. I'm just going to go to the rendering code now and modify it a little bit. So I'm seeing no immediate errors. I'm just going to hard code it for the time being. So we're always going to be using a single frame. So do the synchronization stuff. We acquire the image, and then after that we record the command buffer. And then down here, we just get the command buffer of our frame. And I think that should be fine. So fingers crossed, we'll see how this goes. Okay, love to see no errors. So here we've got our triangle, and this is a little limited by OBS, but just as a measurement, we've got about, what, 810, 800, something like that frames per second. Like I said, I don't think this is going to make a massive difference, but yeah. Okay, cool, it's working at least. So now I want to go into the frames in flight method. One thing I'm going to do is I'm going to take those synchronization objects and I'm going to shift them over to the frame. So if we just go to the header of the renderer, right down the bottom, we should have some synchronization objects defined. And we don't need that rendering info, by the way. Okay, so I'm going to take that and put it in the frame. And that needs to be public so that the renderer can see it. So then I'll go to the renderer source code, and there should be an error. Yep. I'm going to grab this construction of objects and put that over in the frame. Okay, so I'm going to need the synchronization. And I noticed that I made a bit of an error here. I made this synchronization. So I'll just quickly rename that. Pretty sure I misspelled synchronization anyway, it doesn't matter. Great, and just like that, we've got all of our structures. I'll just need to go back to the renderer. And in the rendering code, rather than doing whatever that is, I'm going to access the synchronization object from the appropriate frame. All right, awesome. So that looks like it's all set up. I should probably go to the other source file, which depends on synchronization.h, and fix that typo. Okay, we'll give this a go. And this should just be doing the single frame approach, but with the synchronization objects hopefully working. Okay, great. So that is there. That's all working. And now I'm going to switch this over to frames in flight. So what I'll do is I'll go to the renderer and I'll just give it a variable to track which frame index we're currently working on. Then in the rendering code, rather than hard coding this, I'll put in the frame index. And then right down the bottom, I'll flip that frame index over. So if I take the exclusive OR with 1, that will flip it 0, 1, 0, 1, just like that, and we'll be doing A/B rendering. Okay, so there we've got it. We've gone from about 800 to, 830, 850, something. It's a very small difference. Your mileage may vary. Hopefully, at least, watching the refactoring was fun. Because, hey, when isn't refactoring fun? But that'll be it for now. Again, thank you so much, and I hope to see you again soon. All the best. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.